Now that's the most basic form of a for loop. Now I want you to apply what we learned and also implement this calculate factorial function. And do just that, calculate the factorial. So that, just in case you're not sure, if the user enters 5, you should calculate 5 times 4 times 3 times 2 times 1, and then output the result of that. That's what you should implement now, again by using a for loop. And I'll give you a couple of seconds to pause the video and try this on your own. Thereafter, we'll implement this together. So, did you succeed? Let's now implement this together. For this, we can actually copy large parts of the calculate sum up to number code. I'll actually copy everything and I'll then adjust the code where needed. Of course, we might find a way of refactoring this a bit to outsource some shared code into an extra function that's then reused. But I'll just copy the code for now and add it here to calculate factorial. Now, indeed, the user there still should start by entering a number, the number up to which we want to build the factorial. We want to get that input number so we can use that function again. We want to check for errors and show our feedback if there is an error. And then here, in the end, don't need to output chosen number anymore. We want to build the factorial with help of such a loop. And that's now fairly easy to do. We're not building the sum anymore, but instead the factorial, if you want to call it like that, and use that variable name here and here. But we still need a loop where we loop through all the numbers leading up to the chosen number. But this time, we want to multiply those numbers with each other instead of adding them together. So here we simply use the existing result that we got and multiply that with I. Though there is one important adjustment, we need to start at 1, not at 0, otherwise we'll in the end multiply everything with 0 and therefore get 0 as a result. So we need to start at 1 here as a starting value for factorial. And then when we loop through all the numbers, in the first iteration we'll have 1 times 1, so we get 1 as a result. But in the next iteration we'll have 1 times 2, so we get 2. In the iteration thereafter, I will be 3, and the previous result was 2, so we have 2 times 3, and so on. So that should do the trick. Hence, we need to make sure that calculate factorial is being called here if the choice is 2, and that is the case. And therefore, we should be fine. If we now save everything and we again run this code, now we can choose the second option and enter our number, maybe again 5, and I get 120. And 120 is correct because that is 5 times 4, which is 20, times 3, which is 60, times 2, which is 120, times 1, which is still 120. So that is working, and we now again implemented this with help of the for loop, which, as you can tell, is therefore quite versatile and helpful. And of course, that's just one example where a for loop can help us. In practice, as you write more and more programs, you'll encounter more and more scenarios where a for loop like that can help you. But there also are scenarios where this kind of for loop is not the best choice. And we'll have a look at such a scenario in the next lecture.